So today we're going to start factoring. Let's start off with definitions. A factor is a value in a multiplication. It's a piece that's multiplied. And so factoring an expression means to rewrite it as a product of simpler numbers or algebraic expressions. So if we go back to grade 7, the number 36 could be factored lots of different ways. You maybe did a factor tree, but the ultimate goal was to get the prime factorization at the end of it all, which basically means you can't break it down anymore except using a 1. Oddly enough, it's going to be easier to do this with algebra because we have a more direct route. So taking a look, we can look at this binomial, all right? We want to factor a binomial, which is basically an expression with two terms. They're not like terms usually. And we're going to look for a common factor. So that's a common number or a common letter that we can take out, divide out of each of the terms. So in this particular case, you can divide the 6 and the 2 by a 2, and you can divide the x squared and the x by an x. So what we do is we take this and we're going to suck the factor 2x out in the front and then divide the remaining parts to leave us with a 3x minus 1. So basically you can check this by multiplying it in later using the distributive property. 2x times 3x is going to give me 6x squared, and 2x times negative 1 is going to give me back that negative 2x. So factoring is unmultiplying, it's undistributing, kind of what we were doing just before the topic before. So you can also end up factoring a more complicated expression where you're taking out more than just a number and a letter. You might be taking out a whole bracket. In this particular case, I've got a bracket b plus 5 and b plus 5. It's a common binomial factor. And the way we do this is to basically copy one copy of the bracket out in the front, and then all the leftovers are going to wind up in another bracket afterward. And just like before, we could use the distributive property b plus 5 times 3a and b plus 5 times negative 7 to bring us back to that original expression that we have. Now, if we did FOIL right now, we're not going to get back the original thing because the original is not in simplified form, right? You would have to multiply and get all the like terms. We're going to see that kind of factoring later when we do something called grouping. No, we're not going to jump to the grouping right now.